Good morning. How are you children? Are you watching the videos? Watch children. It's very, interesting. It will give the interesting. Of all the subjects you have to watch it. If any doubts or if you watch, doubts will come. You can clarify the doubts. Is it? So welcome back to our today's session. What is our chapter is going on? Light, reflection and refraction. It's very vast chapter, children. Is it? Yes. So without getting bored for you, some explanation and some videos we are showing. So watch that. Okay? Yes. So light, reflection and refraction. So today's class we are going to learn about the what is mean by lenses. What do you mean by lens? And what are its types? That is concave lens and convex lens. So where these lenses we are using and how the refraction is going on in the concave lens and as well as the convex lens. So I'll show the videos. Through that videos you can watch it, children. Okay? Watch the videos. Carry on.
Ever wondered why the faraway objects appear close to us when viewed through binoculars? What are the two transparent materials in front of the binoculars that make those objects appear nearer? And what is that we use to see very tiny things or to read text with small font size? Why do we wear spectacles? What's used in spectacles? The answer to all these questions in one word is a lens. The two lenses in the binoculars make the objects appear nearer to us. We use a magnifying lens to see tiny things and it has a lens in it. And there are two kinds of lenses used in spectacles. We wear spectacles if we are suffering from certain eye defects. If one is suffering from myopia or nearsightedness, we wear spectacles which have concave lenses in them. And if one is suffering from hypermetropia or farsightedness, we wear spectacles with convex lenses. Lenses are also used in telescopes and cameras. So what is a lens? In simple language, we can say that a lens is a transparent material that bends the light in some pattern. The pattern in which the lens bends the light depends on what type of lens it is. Basically, there are two types of lenses: simple lenses and compound lenses. Compound lenses are made up of one or more simple lenses. For the moment, we are only interested in simple lenses. What does a simple lens look like? A simple lens is a transparent material which is bounded by two surfaces in which one of them is spherical and the other one can be either spherical or plane. Yes, one of them is definitely spherical and the other one can be spherical or plane. Let me ask you an interesting question now. With this knowledge, how many types of lenses do you think exist? There are 6 types of simple lenses. Yes, 6. And this is what they look like. Note that they are drawn in a 2-dimensional space, but you can imagine their appearance in 3 dimensions. A simple biconvex lens is a lens in which the two bounding surfaces are spherical and are curved inside. Similarly, biconcave lens is a lens with 2 spherical surfaces, both of them curved outside. For simplicity, instead of biconvex or biconcave, we call them convex lenses and concave lenses. Plano-convex lens is a lens in which there is only one spherical surface that is curved inside and the other surface is plane. Similarly, in a plano-concave lens, the spherical surface is curved outside and the other surface is plane. What about the remaining 2 lenses? The names sound fancy, right? In these 2 lenses, one of the surfaces is curved inside and one of the surfaces is curved outside. And hence meniscus is also called a convex concave lens. From all the types of lenses above, we are interested in only biconvex and biconcave lenses, which are also referred to as convex and concave lenses. In the next video, we will see how these convex and concave lenses refract light. We discussed about what a lens is and also its various types. It is bounded by 2 surfaces. One of them is spherical and the other Yes, it's spherical or plane. These are the different types of lenses. The two specific lenses that we are going to cover in this course are called biconvex and biconcave lenses. Each one is bounded by two transparent spherical surfaces. Hence the word bi is used. It means two. In a biconvex lens, the two spherical surfaces are curved inwards, and in a biconcave lens, they are curved outwards. One more way to distinguish between a convex and a concave lens is that a convex lens is thicker at the center and thinner at the edges, while the concave lens is thicker at the edges and thinner at the center. Why do we use lenses? What does a lens do? In our previous video, we saw a few examples where lenses are used. In binoculars and magnifying glasses, for instance. But how does a lens function? Well, the main purpose of the lens is to refract the light in some pattern. There are basically two patterns, convergence and divergence. But before studying these two patterns, we first need to understand how the light is refracted by a lens. Consider a convex lens and suppose a ray of light is incident onto it at an angle. This is the normal at the point where the light ray is incident. Now consider a point object here from where this ray is emerging. What will happen when it enters the lens? This ray is traveling from one medium to another at an angle, so after entering the lens, its speed will change, which will result in its bending. Will the speed inside the lens increase or decrease? And where will the light bend? Well, that will depend on the incident medium. Suppose this medium is air. So from this table, we can see that the refractive index of glass is much greater than air. This means that glass is optically denser than air. Hence, the speed of the ray of the light will decrease in glass, and because of that, it will bend towards the normal. Alright, so now what will happen when this refracted ray has reached the other spherical surface of the lens? From there, the ray will be refracted again as it enters another medium, which is air again. You see that this time it bent away from the normal. Can you tell me why? Air is optically rarer than glass, and hence after entering air, speed of the ray increases and it bends away from the normal. And this is how the light ray is refracted by a convex lens. Here only one ray is emerging from the point object, but in reality there are many rays that emerge from this point object and not only one. All these after striking the lens will be refracted in the same way. Did you see something strange? Yes. All the rays meet at a common point. Or we can say that all the rays are focused or converged at a single point. And this is one of the patterns that we were talking about. Convex lens bends the light rays from a point object in such a way that after refraction, all these rays converge at a single point. And this is the point where the image of the point object is formed. If we were to place a screen here at this location, then the image will be formed on that screen. Since the convex lens converges all the light rays at a single point, we also call it converging lens. And what about a concave lens? How do they refract light rays? We will see that in the next part of this lesson. We've seen why a convex lens is called a converging lens. Now let's discuss the concave lens in detail. It refracts the light in a similar way. A ray of light after entering the concave lens bends towards the normal, and when it again enters air, it bends away from the normal. Will the concave lens behave in the same way as the convex lens? Will the rays converge after refracting from a concave lens? If the rays from a point object are incident on a concave lens, then after refraction, they do not converge at a single point. These refracted rays diverge. It means they go away from each other. But wait, since they do not intersect at a common point, does that mean no image is formed? Well, the image is formed. If we were to extend all these rays backward, they all meet at this point. The virtual image is formed at this point. So this is a pattern by which concave lens refracts rays of light. It diverges all the light coming from a point. Hence, it's called a diverging lens. Now let's look at both the lenses side by side. So the convex lens converges all the light rays from a point object, and the concave lens diverges all the light rays from a point object. But usually our objects are big and not just a single point. So let's use an arrow to denote an object. We can take points on the arrow and find out the image for each point. Finally, we join all the image points together to get the complete image. This is a real and inverted image. This is the image formed for an object when a convex lens is used. Are the object and the image of the